Hello, so this video is going to be a quick one on how to design a cell for electrolyte or material characterization. So for your cell configuration, you should always want to do a 3-electrode system. If you haven't already seen my previous video on 2 versus 3 electrode cell configuration, go check that out. It'll explain exactly why you absolutely want to be sticking to a 3-electrode system whilst you're characterizing things. So for your electrolyte, you want to make sure your system won't be electrolyte limited, as in it could be storing more charge, but it can't because there's not enough electrolyte available to store the charge. To fix that, all you have to do is just make sure you always have an excess amount of electrolyte present. So here we have absolutely plenty. Same for the swage lock. If this needs more, there's plenty of room for extra electrolyte to move down. So that way, if you're characterizing a working material or electrolyte, you can get a definitive result that represents the actual capability of the system, whether that be your material or electrolyte. So just like the electrolyte, we want to also make sure that our counter electrode has excess or extra material when compared to the amount of material on the working electrode. This is so that the counter electrode, the part that we don't care about, isn't going to be limiting the part that we do care about, which is either the working electrode or your electrolyte. So always make sure you have excess material on your counter electrode. So since you'll be using a 3-electrode system, that means you will be using a reference electrode. If you haven't seen my previous video before on reference electrodes in supercapacitors and why your choice matters, go check that out, and it will absolutely explain both the importance of a reference electrode and why the type matters. Basically, the video tells you or informs you why you must use a stable redox couple. So maybe a saturated calomel electrode for an aqueous system, and maybe a silver nitrate or silver chloride for a non-aqueous system, and or at least to stick away from metal electrode systems like a platinum wire, a silver wire, or lithium or sodium, as they will muck up your potential reading. So always stick to a stable redox couple for your reference electrode. For the working electrode and counter electrode pressure, we know when we measure impedance that the pressure we apply to the 2 electrodes will change the impedance and therefore the resistance of the system. Same thing when we do conductivity tests, we change the pressure of the pellet that we're measuring, and that will obviously also change the conductivity reading that we get. So it's important to make sure you have a standardized pressure established between both the working and counter electrode. I think for our group, we do roughly 1.7 megapascals for 3 minutes in a hydraulic press. So just another thing to consider for your environment, maybe if you're working with really small currents or potentials, you might want to consider a Faraday cage to prevent getting, contamination from your fluorescent lights or all the noise that you get from all the electrical equipment in the laboratory. Not always super important, but if you're working with very small currents and potentials that are very sensitive, then you might want to consider a Faraday cage. More important probably to consider is an environmental chamber if you can, so that way the temperature of your system is going to be fixed for the entire duration of your experiment. As we know, temperature has a big effect on both batteries and capacitors. So just something to consider if your, laboratory isn't constantly air conditioned. Most of the time it should be, but just another thing to consider. So just another thing to consider when you're hooking up your system, you want to make sure you're not adding any unnecessary additional resistances to your system. So make sure you're using nice and clean, non-rusted clips, and when you attach them to your cell, make sure that they are there's a nice amount of pressure on them and they're just not loosely just sitting on the attachment to your system. So definitely want to avoid anything rusty. Same goes for your channel leads. Just have a look at the pins before you attach it, and if they're looking a little rusty, it's a good idea to just give them a quick sand, so that way they're nice and shiny and you get really good contact. Hopefully this paper will get submitted soon, but it's a really good read. It just reiterates everything I've talked about in this video, and it's not too content heavy. Thank you for watching. Bye.